All right, thank you very much, Melissa. Welcome, everybody. I appreciate the opportunity to present to you guys, and you taking your your time out to spend with me. So today we're going to talk about using the instructional hierarchy to match student skill patterns to intervention. So the purposes for today's presentation is obviously I'm going to introduce and explain the instructional hierarchy and its 4 stages. I'll also, yes.
Thank you.
All right, so excuse me. Also, we're going to talk about how to match specific intervention components to each stage of the instructional hierarchy. I'm going to provide you guys with a scope and sequence of keystone skills and provide some performance criteria. We're going to talk about, what that potentially could look like. It certainly can change from school to school, and it's just a discussion I want us to have. Then we're going to talk about how to troubleshoot and adapt instruction for treatment non-responders. And so obviously we use this, use the instructional hierarchy to come up with an initial way to, to figure out where we need to start with the student and the intervention procedures that will most likely be effective, but not all kids respond. And when that occurs, we need to troubleshoot the instructional environment to try and figure out exactly, what we can alter to improve the performance of the student. And then lastly, I'm going to go over a case that I did here at Oklahoma State through one of our practicum students, where we had it's a 3rd grade student with typical kind of problems with computation. And so I'm going to go through a case, and we'll just kind of talk about how I use the instructional hierarchy to guide this student through their choices and see how that worked for that student. So what is the instructional hierarchy? Well, it's been around for a long time. And specifically, it was developed by Herring and Eaton in 1978. And it is a skill hierarchy developed to systematically match instruction to student skill patterns. And so when they wrote this chapter, really what they were wanting to get through to the readers was they're like, learning is not it's not a simple thing that just you know it or you don't. Learning occurs really over 4 progressively complex situations. So first, the child acquires the skill, then they need to practice the skill to build skill fluency. And then once the student has that skill, they need to generalize the skill, and this can be across time, it can be across context. And then lastly, when a child has mastery of a skill, they can adapt that skill across context. And so instructional hierarchy has 4 stages, and each of these stages necessitates specific instructional components. And so this is the graphic organizer of the day. This should be in your materials, and I would recommend that you kind of have this out and you're kind of looking at it, or can look back to it as I talk. But as you'll see, there's 4 primary stages. So you have your initial, you have your accuracy stage. So you want to build the acquisition stage, where you build accuracy of student responding. And then you have the fluency stage. This is after the student can accurately respond. Now you provide sufficient practice so they can automatize the skill. And then we have generalization, which is up here, would be the 3rd stage. And this is really where you start to challenge that student to use the skill in different ways. And an adaptation is the last stage. And this is when, the child can use this to link the skills that you taught to new, more complex skills. And so if we think about, the science of math, they talk a lot about procedural fluency and conceptual understanding. I think by the time that we're done here in this discussion, we're going to see that up here in this generalization adaptation piece is really where we have is probably the conceptual understanding. Okay, now you're going to see a couple things here. I have accuracy and fluency divided up into a couple different a couple different ranges. So I have initial accuracy and functional accuracy. So initial accuracy is if you assess a student on a particular skill probe, whether that's addition to 10, subtraction from 18, whatever that may be, to me, there's a difference, right? If a kid is 0 to 60%, they're going to need a different intervention than a child that's between 60 and 100. And so we're going to talk a little bit about this today. Same with fluency. You can have, and a lot of times I'll work with students that are slow responders. They're accurate, but slow, usually because they're strategy dependent, doing a lot of finger counting. And so, sometimes the interventions we do for those students will be different. And we've done some research that shows actually explicit timing or time tests, can work really well. But even if a child is accurate, if they're below 10 digits correct per minute, it's not going to work very well. And so, knowing, being able to assess a student in the skill, looking at that skill profile, where they're at in terms of their accuracy and fluency is going to be really helpful to exact which intervention you pick. And so as you'll see with accuracy, you have these in the blue circles over here, you have your instructional components. And so in essence, what the instructional hierarchy said is if a child is failing to respond accurately, you're going to have your interventions are going to need to include these instructional components. And that's demonstration, modeling, cues and prompts, and immediate feedback. Once a child can do something accurately and we move to building fluency, you're going to cut out some of the components. And here, all you really need to do is drill and practice. And so this is, again, when you would do the time testing and really just let the kid, have ample practice to build that speed. Another thing you'll see that's different about this instructional hierarchy than others is I like to focus on declarative skills and procedural skills. And I think that this is really overlooked. If you read about the instructional hierarchy outside of my presentation of it, people don't break it down. But I view this as if I'm a teacher or a consultant or a school psychologist, and I'm trying to task analyze the situation with the student. Sometimes students can't do skills because they don't they don't appropriately apply a procedure. Sometimes it's because they don't have the necessary prerequisite declarative skills. And so let's define these. So a declarative skill is a what? And so, for example, if you would ask me what's 3 plus 9, I know it's 12. Right? There's no procedure I need to engage in. I have it memorized. It's 12. Now, if it's a first grade kid or a second grade kid, if you ask them what's 9 plus 3, they could, or let's say 3 plus 9, they could count from 3 and then count up 9. If that's the case, they're actually engaged in a procedural skill. And so even though it's the same cue, knowing as a student using a procedure to figure this out, or is it a memorized declarative skill? And so the keynote today, my guess is, I wasn't able to see it, but my guess is he talked a lot about working memory and automatizing facts so that you could open up working memory, to focus on some other aspects of teaching to learn new skills. And so what this really looks at is saying, what are the declarative skills? Can we get kids to kind of memorize keystone skills that we know they're going to need for future problems? And again, so if we think about that with this finger counter, right? What are the declarative skills for a finger counter? Well, they need to be able to have a verbal chain, right? So they need to be able to count 1, 2, 3, 4, 5, 6, 7, 8. They need to have one-to-one correspondence. So here are some of the declarative skills: number identification, being able to write numbers. These are all declarative fact skills that child would have. And then the procedure obviously would be the counting procedure. And then sometimes teachers will use procedures such as, number lines or manipulatives or 10 frames. And so a lot of times, right, students never really memorize these basic facts because whenever they see a fact problem, they basically engage in procedural skills. And if I have any 4th, 5th, or 6th grade teachers in the audience, which I'm sure I do, those kids kind of drive you nuts when you're trying to teach fractions and other higher order skills, because again, they're just so overwhelmed because the base information to do those higher skills, they haven't memorized yet. And so the instructional hierarchy, when I look at what kids can do and can't do, it's assessing them, it's looking at their accuracy scores and their fluency scores, and then kind of matching up to these interventions. Flashcard drill, cover copy compare, tape problems, and explicit timing. I'm going to go over each of these today. And then also think about, am I focusing on teaching a child to memorize a kind of a tool skill, if you want to call it that, so they can use it across different problems, or am I trying to build procedural skill? And when we get to generalization, a lot of times when we promote generalization, it is through teaching a child a procedure. And so if they have the prerequisite tool skills memorized, it's going to be much easier to teach them those skills. Okay, down here I have intervention assessments and essentials, and then troubleshooting for non-responders. And so this is kind of a one-stop shop as far as a graphic organizer goes. So the intervention and assessment essentials is we need to establish a scope and sequence. We need to determine instructional match using instructional hierarchy. So is the child accurate or fluent, or are we having a generalization issue? You need to set goals using mastery criteria. And so what I see a lot is because students are accurate, we go ahead and just move to the next skill, and we fail to build that memorization and automaticity of the sub-skills, which I think hurts the efficiency of our future instruction. We need to define the curricular scope of the target skill, and you're going to hear me talk about curricular scope and set size, and what that really means is how much are you going to teach at one time in one day. And then interventions, logistics, frequency, how many times a day are you going to do it? And then the dose is how long are you going to do it? When we troubleshoot non-responders, we verify selection of the target skill. And so if you do an intervention and it's not effective, then one of the questions you're going to ask yourself is, should I work back? And so if you have a scope and sequence, you can kind of systematically go back and assess the child on these tool skills to see if they're maybe inaccurate at some tool skills, or maybe are disfluent in others. And so you may want to slice back to increase skill fluency. Verify instructional match. So make sure that if you choose an intervention and it needs to build accuracy, you need to make sure that demonstration, modeling, cueing, prompting, and feedback, that those are ingrained some way to your intervention. Are you teaching too many problems? A lot of times we have non-responders because we're teaching too much. The instruction is appropriately matched. It's the right skill. But if you teach a kid, if you're trying to teach a kid too many things at one time, it's just a waste of time. And we'll talk about that here in a bit when I go over the specific interventions. And then also issues is you don't really intervene enough with the student. And so the intervention is too short or infrequent. And then lastly, if a student's not engaged, they're not learning. And so again, we're going to talk about this in conjunction with the individual interventions, but then also, at the end, when I go through kind of this case study, I'll show how I used, these concepts to go ahead and problem solve. Now, one of the larger overarching ideas I want everybody to kind of also look at is on the sides, you have these arrows. And so you have a curricular scope arrow that's narrow to broad, right? And again, that's how much you teach at one time. So when a child is learning, when they're inaccurate, you're going to teach very few items. And then you're salient, and on the other side, you have saliency of cueing and feedback. And so you're going to have a high level of cueing and feedback. Now, what you'll see is as you move students up to independence, right, you're going to fade the saliency of your antecedent and consequent conditions with your instruction, but you're also going to broaden out how much you're teaching. And so set size kind of increases as you move up the instructional hierarchy, and the saliency of cueing and feedback decreases. And so again, I just spit out a lot of information. I'm going to kind of now break it down, go through it, and then try to bring it together with a case at the end. Okay, here's the computation scope and sequence. And I go over this just because one of the big challenges, I think, for math teachers or elementary teachers teaching math is that you're expected to teach everything under the sun. And so it's a mile wide and an inch deep, and it gets very difficult, especially for students that, you know, lack sufficient prior knowledge coming into your grade. And so one of the things I always preach is that we need to do a better job of figuring out what we need to teach and when we need to teach it, and what those keystone skills, those foundational pieces are that every kid needs to get. And so, you know, this is in a handout you guys have. This isn't the end all be all. This isn't set in stone. This is what I use. I think it's generic. It should match most curricula. It won't always. And so clearly, like if you implement some of these things in your building, you need to know what your scope and sequence is. But in every building, right, first grade teachers should know what kindergarten teachers are teaching, and kindergarten teachers should know what a first grade teacher expects kids to, where they expect kids to be at, all through the grades. I think sometimes, unfortunately, people get siloed, and you know, and so, for example, if you're in third grade and you may have to go back to a student that for their addition skills, and I that would be frustrating to me. It would be great if you got folders on students and you could see, you know, through the grade span, here are interventions we did, here's how the student responded, here is where they were at, and it would really help expedite that problem solving process. All right, and then the last thing I'll talk about is mastery criteria. What is fluency? It's a difficult concept. People disagree. Research will cite different levels. I've seen 20 digits correct per minute in grades 1 through 3 labeled as mastery. And that's shocking to me because that's a student knowing a math problem every 3 seconds. And clearly a student that does that is going to be very procedurally dependent. They won't have those skills memorized, and it kind of starts that chain of, of being procedurally dependent, and then, you know, really overwhelming the student with procedures when you get to your, multi-digit addition, subtraction, and whatnot. And so anyway, these are suggestions again. This is just, there's not a lot out there on that. This is what I use. And again, I set a lot of my end criteria at 40. I'd like to see them at 60, but my interactions with teachers is they don't like to keep them in a skill that long. But again, I want to see a kid be able to do these kind of sub skills, whether it's sums to 18, subtraction 18, especially those 4 big skill areas. I want to see him be able to do 1 a second and really, yes, digits correct per minute. Thank you for that. And I want to see kids do this. Now, some people argue about, do you do digits correct per minute or problems per minute? They do digits correct per minute because it has a little bit more variability to it, and it's a little bit more sensitive when you're progress monitoring. But problems per minute is okay as well. Again, if you can do 40 problems a minute, that's probably going to be in addition, you know, maybe up to 60 digits correct per minute. And so again, I never shy away from encouraging high levels of fluency, because I think it's, and I have data that shows that it's really important to future skills that you teach. Okay. Yes. So if you do, yeah, digits correct per minute. So here's a question on the chat. It's a silly question. It's not a silly question, but when the sum of a 2-digit number, you count each digit. Yes, you do. And when that's important is when you see criteria or you have district-wide assessment and it's digits correct per minute, not problems per minute, you're going to be comparing apples to apples. And so, you know, making sure that you're just using scoring and reporting skill levels in the same way as your district-wide assessment is really important. Okay, so linking instructional components to each stage. So I went through a lot there fairly quickly. But I want you guys again to get the the basics of the skill hierarchy. Understand that you need to have a scope and sequence because that's what you need to assess through to get your accuracy and fluency scores. And when a child isn't where they need to be in a grade level standard, you want to be able to test back to make sure of what that student needs. Excuse me. And then obviously skill criteria. We don't want to move to the next skill until it's learned at a fluent enough level. So linking instructional components to each stage. So acquisition is increasing accurate responding. And so big ideas when promoting accurate responding, students will need to complete a learning trial to promote accurate responding. And this is, you'll hear me say antecedent behavior consequence. Also, I'll say stimulus response feedback. These are the same things, but in essence, you provide something to the student to show them what's expected or how to do it. The student responds and you provide feedback. So the antecedent condition shows the student what needs to be done. The child exhibits the skill you want to see, and then you provide immediate feedback in the form of praise or correction. So if they get it wrong, you just say, if you're like, what's 6 + 3? And they say 8, you say, no, 6 + 3 is 9. And if they get it right, then you say, good job. And, and that's how simple it is. Instruction, and going back to this, if we think about what we do in classrooms, this really kind of fits, right? You go up in front of the classroom. You may kind of show students how to do the problem. So you kind of model how it's done. You ask a student or two to come up, work something on the board in front of the class. So they're modeling modeling to the class. They sit down, they do an independent, maybe seat time, work on a worksheet, they hand it in, you grade it, you provide corrective feedback. But that antecedent behavior consequence loop doesn't happen till the next day. And so a lot of the interventions I'm going to talk about have it for every single problem. And that's what really strengthens flashcard drill, cover, copy, compare, and tape problems over traditional intervention. So instructional components to promote acquisition. So we got 3 here: demonstration, modeling, and cueing. And those are the antecedents, and then feedback is the consequence. But demonstration, modeling, and cueing are not the same thing. And if you remember what I talked about as far as fading saliency, the most salient is demonstration. You show the child how to do it, right? The next would be a model. So this is where you would provide a worked example that the child could look back at, okay? The last one is just a prompt or a cue, so they see the problem, and then it signals to support the skill. So you're basically now removing or fading that antecedent piece of the intervention, and then the student responds and feedback is provided. And so again, I keep hitting on this. It's of high importance for you to understand the saliency of antecedent and feedback conditions are important, and the goal is to fade over time. So here are our big 3 interventions that have been shown, empirically validated, to increase accurate responding. And so the first one we've all heard of, right? Flashcard drill. This is generally done one-on-one. The teacher will show the student a flashcard and demonstrates how to respond. So if I'm a kindergarten teacher and I'm teaching just letter identification, I may be like, this is a 2. What's this? And then I'll pause, and then I'll signal the child to go ahead and provide the answer. And so then they say 2, and you say, good job, and then you go to the next. All right, cover, copy, compare is a little bit different. Where flashcard drill, the teacher leads it. Cover, copy, compare will provide a worksheet in front of the student, and it basically has a bunch of worked examples or models of the problem and the answer. The student looks at the model, covers the model, they respond to the model, and produce a response. So a lot of times it'll be writing, and then it uncovers and it looks at the model, to provide the feedback. And so if we think about the saliency, right, you need a teacher one-on-one to kind of run the flashcard drill. Now, granted, you could do it in small groups, but those are difficult to manage, but can be done. Cover, copy, compare is basically a self-directed flashcard approach, right? I mean, if you think about the flashcard would maybe have 3 + 4 is 7 on it. And you may say 3 + 4 is 7. What's 3 + 4? And then you would signal the student. Well, that's already on the cover, copy, compare worksheet. And then tape problems is the last one. And this is just a worksheet. And I have examples I'm going to show here in the PowerPoint to show you what these look like. But tape problems is basically a series of problems. And the tape reads the problem, provides a brief 2-second delay, and then provides the answer. And so again, now we're removing those antecedent conditions. We're just saying 2 + 4 is 6, and the child's trying to beat the tape. All right, so flashcard drill and cover, copy, compare. Again, I'm going to talk about those together just because they're so similar. Both are accuracy building procedures using a stimulus response feedback structure. And with flashcard drill, the stimulus is presented and a student provides a response and feedback's provided. With cover, copy, compare, like I said, they look at the model, cover the model, provide a response, and check response. Flashcard drill is good for students who cannot accurately respond. So teacher-led often requires a 1-to-1 ratio. These are these kids, like when you initially have to build a skill and they come in with nothing. So your kindergarten, your first grade kids, you need to be so highly salient with your instruction. Very small sets, lots of repetitions, very clear antecedent and consequences, very consistent with your instructional routines. But in cover, copy, compare, I generally would use that after a kid was more highly accurate, so 60% on up. And these are good for students who cannot accurately respond or are strategy dependent. And so again, student managed requires smaller sets, and students write the model. It's less salient, it's lower rates of responding, but the real positive of cover, copy, compare is that you can differentiate and you can provide every kid with a worksheet and you get permanent products for every kid, right? So you know exactly how the child's responding. Oh, Shannon, I'm sorry. Let's see. I'm sorry, I'm a little late on your comments here. So to me, when you teach to so Shannon's question is, you said flashcard drills do something different than what we normally do. And when I say that, I'm assuming that when teachers do class-led activities, that a lot of times there won't be that immediate feedback on every single item, right? So kids will sit at their desk, they'll do things, they hand things in later. And so then they get the feedback the next day. Okay, so examples of how to differentiate cover, copy, compare. Cover, copy, compare is a great intervention. It's good because you can do it class-wide. Again, you can have kids working on different things, but with young kids especially, the writing piece is very high effort and it slows down their rates of responding. So let's talk a little bit about how you can differentiate it. So you can differentiate across problem types. So you can do basic facts where they literally just look at the problem, like 6 + 7 is 13. They cover it, they write the problem and answer. You can do fact triangles where it would show just a 6, 8, and a 14, and a kid could write 6 + 8 is 14, 8 + 4, or 8 + 6 is 14. You could also do a C, write the reciprocal. right? So if they see 6 plus 7 is 13, then they would write 7 plus 6 if you're trying to teach fact families. Using different response topographies can also lead to increased rates of responding. And so traditionally we use written. And so the kid sees a problem, he covers it, he writes it. Low response rates, although it does obviously targets writing skill as well as kind of getting the fact, but you have a permanent product, which is really, really pertinent when you're doing class-wide instruction. Kids can also just do it verbally, see, say it. So you take the writing component out. And this increases rates of responding, but then it eliminates the permanent product. And so if you ask your students just to kind of sit there with their cover copy compare sheets and kind of whisper, what they're doing, you would have no way to validate whether they were actually responding. So if you had non-responders, you wouldn't necessarily know why, but the research shows it works as long as they engage in it. Now, there's also another called cognitive cover copy compare, and this is where they see that they basically do everything subvocally, so they think it. It's shown to work, but it's again high inference because you're not observing the child actually engaged in it. But if we think about it, if you do written, it's high effort. Some kids will kind of pull away, they'll lose engagement. If you're in smaller groups, you can sometimes put in the verbal piece. What I'll do a lot of times is have a kid do a probe written, and then I'll say, would you rather do this verbally? And I'll give them choices so they can kind of pick different iterations to do, but this will increase rates of responding. And if you have kids whisper, right, at least you can try and read lips and kind of make sure that they're doing it in small groups. The problem with verbal in the classroom is it can become very distracting, and that's a problem. And so that's when you can go ahead and you could do this cognitive piece. Although again, a kid could just sit there and look at the paper and not engage in anything. And so that's why we generally require the written. But anyway, I want people to understand that there's different ways you can go about this that have different pros and cons. So again, pros for cover copy compare: ensures errorless learning, it's fully differentiated and provides writing practice, which we know kids need. Cons, low response rates. Students will probably need some reinforcement with this, and you need to make sure they're doing it with fidelity. And so a practice tip: large item sets with short practice times are a waste of time. Okay, now I have a website. It's free, and I have cover copy compare forms. And so if you're like, who creates these? Where do I get them? I have all of those things for you guys. Okay, so here's examples of the cover copy compare worksheets. Okay, so if we look at this initial worksheet, it's 9 plus 8 is 17. So if I'm a kid, I just look at it. I say 9 plus 8 is 17. I cover it. I write 9 plus 8 is 17. I uncover it. I match the two. That's how simple it is, right? But if you notice, there's only 12 problems here, right? And then we have, I think, the reciprocal problems over here. And so basically a kid would get 2 repetitions of 12 problems. And I usually would have them do at least 2 sheets, right? So I start, when I initially will intervene with kids, I'll start with a certain amount of problems with a certain amount of repetitions. And if they fail to respond, then I can think about altering that set size to increase more repetitions with less items. Robin Cotting did a study, and she used cover copy compare this way. And so here she had the problem written, but not the answer. And so this, you could still get the permanent product of writing the answer, but it increased student rates of responding. My only worry is you want to always connect this 3-term contingency, right? 9, 8, 72. And so, to me, they could just transfer this answer only, and they wouldn't be pairing the 3-term the 3-term problem, which may be an issue. Okay, or question here. Do you know if having them repeat the question helps so they are not just memorizing the answer? I want them to memorize the answer. Most students that will work on this And if you look at the skill sequence, they can already count. They have counting strategies. They can do one-to-one. They kind of conceptually can explain and have the vocabulary of more or less. But then to me, there's a time that we need to memorize the declarative fact so that we can move on and teach other things. In these are pre-made. And so more than likely a kid, and again, students may know all of these facts using procedures, but it doesn't mean they have them memorized. And again, we can talk later about, because I know there's a huge camp against memorization. I think if you listen to the keynote speaker today, he probably highlighted why it's important to kind of have things known to automaticity. So when you go to learn more complex procedures or concepts, right, you're not thinking or engaging in all of these procedures to do kind of these tool skills or base skills. And so now if we think about, this is a good question, do you include a mix of new and already learned facts or just new facts? If I had more time, I could go over all the different flashcard drill approaches, incremental rehearsal, folding in techniques, and traditional. And again, that's the saliency that the flashcard drill provides you. This is again a little more standard protocol. And again, this is why I want kids to be, again, I want them to be accurate probably before you do this, so they can identify their numbers, write their numbers, they can count one-to-one correspondence, and can do different tasks, prerequisite tasks like that. The mind, cover, copy, compare for fact triangles. So here, if you're doing multiplication, right, 8 times 9 is 72, 9 times 8 is 72, or you could do write me one multiplication, one division, just depending on what you're teaching and where you're teaching, but those part-whole relationships can be done there. All right, tape problems. Accuracy building procedure that uses a stimulus response, fluency structure, or students stimulus response feedback, I'm sorry. So it provides an audio prompt, 2 seconds to write, the answer is read. Audio files and corresponding worksheets are at this link. And so again, you just print out the sheet, and then there's a tape, an audio file on there. You put, you push play, and the child works along. So it's good for students who are slow and accurate and who are strategy dependent. Comparative intervention studies show tape problems is generally superior to cover, copy, compare. The problem is if you do it class-wide, everybody has to be working on the same skill. And so these are 3 approaches that all work really well, right? Like there's good research evidence for all of them. Flashcard drill, again, I think it was, let's see, when we talk about interspersal procedures and other approaches, you can really individualize known to unknown ratios. It's one-on-one with the student. It's just very salient with the antecedent and consequent procedures, but it takes a lot of time and resources. Cover, copy, compares in the middle. The rates of responding aren't all that fast, but you get a good permanent product. You can do it class-wide, and you can differentiate. Tape problems works really well because it has high pacing. The tapes I make, you do 1 problem every 5 seconds, right? So if we think about that, you're doing 12, kids doing 12 problems a minute. And so again, you do this for a short 4-minute burst, and a kid, will respond a whole lot of times compared to what they would maybe even over a 20-minute, independent seat work intervention. But again, you have to have the class all work on the same problems. So pros and cons for class-wide implementation. Rapid pacing is good, ensures those high rates of responding. The cons, it loses its effect as initial fluency rates get lower, and all students work on the same skill problems. and students can cheat the procedure, right? And that's the thing with all these. With like with flashcard drill, they can just parrot what you say, and they're not actually looking at the stimulus and not pairing their response to the stimulus. With cover copy compare, I've seen them look at it and just go like 5 and then 5 and then a 4, and then they'll write a +4 and then a 9. And so they're not really pairing the stimulus and the response. And so they're kind of cheating the process a little bit. With tape problems, they can just wait for the tape to say it, right? And then they just write the answer. And so obviously always being up, scanning the room, watching kids do this and how they're interacting to make sure they're doing these interventions with integrity is of heavy importance. Okay, so then this is just what a tape problems worksheet looks like. So again, it would be 4 + 2 is 6, 8 + 7 is 15. And so again, the kid just needs to try to beat the tape. All right, so fluency, to increase fluency, we don't have to have those antecedent conditions anymore. We increase the amount of rate practice time to automatize the skill. We provide reinforcement to increase motivation, make learning fun and meaningful. So incorporate goal setting and self-graphing to try and build confidence in students and shape attributions. Salience feedback is confined to performance on a set of items. And so in all these previous interventions, every single item would have feedback with it. Okay, here you'll just time a kid and you'll see how many items they get per minute. And so you see how you're increasing that set and you're beginning to fade the feedback from per item to kind of per the set of items. Intervention sessions should be brief, 4 to 8 minutes, and distributed across the day, if possible, 2 to 3 times. So again, I talk about memorizing facts. To me, it is probably the most underutilized instructional technique. And we all know, if we've listened to people about math, they'll say time tests are bad, memorization is bad. But of course, some of you guys have been talking about phonics, and we have no problem with kids memorizing their phonics skills, right? And knowing that A says ah or B says buh. We don't want them to think about it. We're not teaching them conceptually what it means. Sometimes certain skills just need to be memorized. I'm in the camp that your basic facts needs to be memorized, but also understood. And so we can talk about that a little bit later. All right, so explicit timing is nothing more than you provide students with an instructional level task, and it's of, again, high importance. Do not time kids on things they cannot do or cannot do well. That is frustrating. That if anxiety is caused by time tests, that's why, right? We're timing students on things they're not ready to be timed on. Give students an amount of time to complete as many problems as possible. Repeat 2 to 4 times per session. Praise effort and task adherence. And then I like to incorporate goal setting and self-graphing. And so the research has been clear on this for a lot of years. If you just tell kids to work on something, or if you kind of give them an antecedent timing procedure of, do as many you can in a minute, ready, go. They've shown over and over again that it increases the amount you're going to respond during that period. And so it's highly effective in increasing rates of practice. And as we know, opportunities to respond and practice is really it's the straw that stirs the drink, so to speak. Now, explicit timing and drills can be boring, but they can be fun. And so goal setting, have a student write down the score of their last practice session. On the final practice session of the day, challenge the student to beat the previous day's score. After timing, count the number of correct items and compare to the previous score. Praise and provide reward for beating the score. Praise effort if the student fails to beat score, assuming, of course, they're giving a good effort. Self-graphing is pretty self-explanatory. You use a daily graph to fill in a visual representation of performance, total performance from a final practice session, put on graph, have students fill in to show the level, and have the student tell you if they beat their previous score or not. Praise and provide reward for beating score, and praise effort if the student fails to beat the score. And so again, yeah, Spring Math is a wonderful program, evidence-based practices. And again, this can be done poorly or it can be done well. And again, we want kids to experience success. We want to set kids up for success. Practice is empowering the students. When they practice and they get better, for some students, it's the first time they've ever felt success in the classroom. And they're shown with things like math, like, hey, guess what? You practice, you pay attention, you try your hardest, you practice, you get better. So when I talked about attributions, those are the types of things. We want kids to choose to engage in math tasks. To do that, math tasks have to be reinforcing or successful. And so, setting up these conditions so that kids can be successful is important. And again, the instructional hierarchy, waiting till kids are at least above 10 digits correct per minute before you would do time procedures is important. And what the research again shows that I've done some that shows if it's under 10 digits correct per minute, explicit timing does not work any better than a control group. Okay, so explicit timing uses a fluency building, and it uses a stimulus response feedback, right? So there's no antecedent there. It's just the problem, the kid responds. The student's presented with a series of problems without the answers. They're given a fixed amount of time. Again, it's effective for students who are slow and accurate, but make sure that they're above 10 digits correct per minute. And tape problems, it worked for students under 10 digits correct per minute. Above 10 digits, tape problems work the same as explicit timing. My guess is if you get kids up to 20 to 30 digits correct per minute, that's when explicit timing would begin to separate itself out from tape problems. And again, sometimes we go below that because in explicit timing, again, you can differentiate what students are actually working on as compared to tape problems where everybody does the same thing. For older students who are lacking basic math facts and fluency, I recommend the same exact thing. And I think that older students, you'll see they can accurately do it. They just out of count all the time. And so it takes so long and so much effort. This is why they choose not to engage in these tasks. And so again, how much time does it take to get the child to memorize it? So when they have to move to multi-digit, or they're doing fractions, or they're doing different types of more higher order math, they just don't have to think about those basic tool skills, and they can really focus on, again, the procedural fluency and the conceptual understanding. What I don't want you guys to get me, I'm an interventionist, not a classroom teacher. And here is my thought process on this. And if you come to my presentation following this one, I get at this. Classroom teachers teach procedural fluency and conceptual understanding. And their job is really difficult when kids come in and don't have basic tool skills. And so what I want to do is provide, and what I've done with my website is try to provide teachers with short duration, high intensity interventions, so that if you do it every day and you do it at the right time, hopefully kids will have these tool skills automatized, which will allow classroom teachers to basically do their job much better. And again, I have some data I'll present in the next presentation that shows that it increases broad math scores if you do what I recommend. Okay, so pros and cons, class-wide implementation, high rates of responding, it's fully differential, works best with goal setting and reinforcement. Cons, requires correct instructional placement. And again, time tests can be used incorrectly. And then the last thing, be wary of strategy dependent students. Explicit timing may just prompt procedure use. And again, there's a right, and again, I'm sure some of you are like, what are you talking about? We want kids to use strategies, and there are times that you definitely want to, and when you're teaching certain concepts, but what I'm saying is there's also a time that kids need to move on from those as well. And in my case example, we'll see, see an example of that. And so again, this is just what the, from the website, this is explicit timing, how to train the student in it. And this is what the worksheet looks like. And I want people to recognize I have 12 items on here. So it's 12 items, 12 items, 12 items, 12 items. So if a student does this, right, they're getting 6 repetitions of the 12 items. So generalization and adaptation, so generalized responding. Students often fail to generalize across time, problem formats, and skill. And so across time, a kid knows it one day, they don't know it the next. And across problem format, a student has difficulty responding when the stimulus is altered, right? So this could be, the student could sit there and count bears or manipulatives, right? Whatever that may be, but then you give them a number line for the first time, they don't know how to use it. You'd have to teach them how to do that. Same with like, if a kid can add basic math facts, but the first time you show him a 3 by 3, even if it's without regrouping, they have to know to do column addition. And so you may have to show them that. Usually those types of things generalize, sometimes they don't. And then across skill, you need to specifically teach procedures to combine component skills. And so basically if a kid has as basic fact, but they can't do multi-digit addition with regrouping. I've done research where I've had kids up to 80 digits correct per minute, and that did not generalize to regrouping until I taught the procedure. And then when I taught the procedure, they made very aggressive growth. So the declarative skill, memorizing the fact, was one, but to do the larger skill, I had to put in the procedures. And when we did that, it worked well. It's a question: do students who have good fact fluency have better conceptual understanding down the road than people who use tools or calculators? Not necessarily, but probably, and I'll tell you why. We want, if a student has something memorized, but you never sit there and teach them how to use it or why they use it, the child's not going to develop conceptual understanding. I'm not saying that if they memorize their facts, they're good at math. Just like a kid that's, knows his phonics isn't going to necessarily know how to read. We have language components to math. We have, there's a lot of different things. To me, what it does is it sets the stage for the teacher when they go and they explain, this is how you use it. This is why you use it. They can think about those things because they're not thinking about how to count up from what, or do I need to use a doubles plus 1, or do I need to make tens, or do I need to count from the larger number first? I mean, think about it. When a kid's engaged in this, they're focused on how to use a procedure to get at a problem. They're not getting of how to use the problem to kind of form and add to a larger concept. So that's a good question. And that's why I think that fact memorization is so important, is so that we can focus on, so classroom teachers can focus on the larger issues at hand, which would be procedural fluency and conceptual understanding. So across time, generally, if you take kids to 40 digits correct per minute, they're probably going to retain it. This graph down here was a study I did with a girl. She had an IQ of, I think, in the 50s, so intellectually disabled. And now this was only on 4 problems, but look at this. She had been working on basic math facts for years, and she was around 33% accurate, 5 digits correct per minute. Within, I think, 6 days here, or 7 days, this was less than an hour of instruction, this child was up doing close to 25 digits correct per minute. And then over spring break, she maintained them, right? And so by having this student engage in procedures, obviously ID, the child was cognitively limited, but because they were having them focus on procedures, the child could never, they never linked the stimulus and the response. When we got rid of that, right, the child memorized it. Okay, across problem type, students need opportunities to practice similar problems and explain how they are alike and different. And so this can be real simple, right? Like vertical versus horizontal problems. When I talk about basic algebra problems on my website, I have what are called closed problems. And it would just be blank plus 8 equals 15, right? So the kid would have to put 7. Facts and word problems, right? Sometimes if the child already has the language, but they're missing memorization of the basic facts, if we can do that, you'll see generalization across problem type. But then across skill, sometimes if we task analyze the skill, let's say you got the kid up to 40 to 60 digits correct per minute and they couldn't do the math problems or the word problems. Now you would have to look at, is it a decoding skill, a vocabulary skill? You would rule out a basic fact skill, but also closed facts, right? Like if we're doing word problems and you're like, Mitchell has 15 apples and Brian has 8. How many more does Mitchell have than Brian? Then obviously if the kid set it up as blank plus 8 is 15, then if they had that skill already, that wouldn't be, they could just focus on the wording and what they're trying to get at. And so ask the student to tell you how to combine them. Does the student have the necessary procedural skills? Find errors, provide feedback, incorporate I do, we do, you do with work examples. And then once they're accurate, provide sufficient practice. So here's an intervention I have also on my website. It's just procedural, cover, copy, compare. And so this literally, I would work the first one and show the student 6 plus 9 is 15. I carry the 1, 7 plus 7 is 14 plus 1. So 15, I carry the 1. And then I would have him do it and he would talk me through the procedure, right? And then I would have him do it independently. And then once he could do it independently, now he does this. And you see he has this antecedent stimuli that basically kind of organizes how he's going to respond. And these will all be where you're regrouping every single time. Then we have this, we remove the cues. And I think the first 2 rows, the child will be regrouping a majority of the time. And then the last time, sometimes he regroups, sometimes he doesn't. And so just so everybody's, clear on a I do it, we do it, you do it, or a worked example. And then how you structure this curriculum is very important. And remember, I would not put a kid in this intervention unless they are already at 40 digits correct with 6 plus 9. Because think about when you have a child and they're going 6 plus 9, oh, 9's the bigger one. I'm going to count up for that. And then they count. And then they're like, okay, now I need to carry this. Okay, now I need to count 7 plus 7. Right. And so now you're just just like you wouldn't do a flashcard set with 18 unknowns in it. Why would you sit there and clog the kid up, simultaneously have him use and try to learn multiple procedures at one time? It just doesn't make sense. Right. And so, again, the keynote speaker today, I'm sure, talked about the limitations of working memory. And if that's not open, we can't attach what we're learning to what we already know. So if kids don't have those basic tool skills memorized, they have, it really limits their ability to begin to learn things in that conceptual sphere. All right, so conclusions. 4 primary procedures to build accurate and fluent responding. So accurate responding requires stimulus response feedback or learning trials, flashcard drill, cover, copy, compare, tape problems. Promoting fluent responding requires practice and high rates of OTRs, so flashcard drill and practice. Cover, copy, compare, tape problems. Everything, if you're increasing fluency, or accuracy are also increasing fluency, but again, at different times, these will have different effectiveness. And so again, above 10, you're going to be good with either explicit timing or tape problems. Below 10 digits correct per minute, you probably want to use cover, copy, compare, tape problems. Okay, be mindful of the saliency of the antecedent and consequent procedures, and then be mindful of how to manage that curricular scope. Okay, so here's a case study. I think we got 15 minutes. I'm trying to get this done in 10, and I'll field some question at that point. All my materials are free. You go to www.factsonfire.com, and so, okay. So my case, this was a 3rd grade student, referred for testing. Initial assessment, sums to 18. The child was at 4 digits correct per minute with 33% accuracy. All right, so the problem analysis, the student could identify her numbers, she could count, she could write. She was just using an incorrect counting strategy. So we did a quick 10-minute counting intervention. She was counting, from the wrong number was all. So we fixed that. It took 10 minutes. 18, so then we reassessed her sums. Well, she was 100% accurate, and now she was at 18 digits correct per minute. And so we updated the problem analysis. And again, the student was strategy dependent and disfluent, so slow but accurate. And the team decided to do an explicit timing intervention. I tell my students, it's your case. You make a hypothesis, you test it, you see if it works. And so they just said, the student's almost at 20. We're just going to do explicit timing. We're going to see how it goes. And so they did explicit timing with worksheets, sums to 18s, no zeros and ones on those probes. Also included goal setting, self-graphing, and reward. Intervention logistics met daily with the graduate student, and 3 1-minute timing. So this is about 5 minutes a day. And the goal was to improve the kid 1 to 2 digits correct per minute per session until the student could write 40 digits correct per minute. So the student started at 18, and after 10 sessions, which had been 50 minutes, she was at 24 digits correct. So the student increased about 0.6 digits correct per minute. And this was well under the goal that we wanted to see. And so if we thought about, if we continued this way, it would have taken 27 more days of intervention, which was not acceptable. And so, when we looked at the intervention, and this was after 2 weeks, and this is the great thing about using small sets, is you get reinforced, and as far as you can make decisions quickly. But anyway, we said the problem still exists, so let's troubleshoot to intensify. So work back. No, we already, and this is the thing about assessing across that skill hierarchy, across the scope and sequence. We knew the kid had the necessary prerequisite skill. Was the student engaged? It was reported the student was working hard and focusing. Was the intervention too short? Yes. Like, I get so frustrated, but my students would be like, that's all I got. That's all the school would give me was 5 minutes. And I'm like, well, I don't know why, if a kid's behind a grade level or 2, you expect to catch that kid up in 5 minutes a day. Was the correct instructional match? Yes, as far as this child was slow and accurate. So, a fluency building intervention, it was okay, but I had questions because I don't like the procedural. I've seen too many kids just get stuck on procedures and they never move off. I don't know if we have any high school teachers in there, but I mean, there's kids still using touch points, right? And touch points is interesting, right? You got a 3, you have 3 dots on it. It's, it's quantity on top of a number. It gives the kid a strategy. But again, if they never move on past it, it basically delays their development. And then teaching too many problems, well, that was unclear. So we retested the student. And what we did here to retest is, so the child was at 24 digits correct per minute on their sums to 18. But when I measured them sums 2 to 10, they were at 40. And when I measured their performance, or had the student assess them sums 11 to 18, the student was only at 4 digits correct per minute. And now she was accurate across all assessments, but guess what? Sums to 10 was mastered already. And sums 11 to 18, the student was actually in the frustration range. And this makes sense because she was counting up. So if it was 3 plus 9, for example, she literally was like 3 and then 4, 5, 6, 7, 8, 9, 10, 11, 12, right? And so my hypothesis was the student was making insufficient progress because she was practicing the counting procedures. And because she was doing that, she wasn't linking the problem and the answer, because it was like, here's the 3, now count on. By the time she did that and she wrote the 12 down, she didn't link 3, 9, 12. Right. And so earlier they asked, like, should you have kids memorize? Like, yes, you should. But I mean, I want the kid to understand a 9 means a quantity and a 3 means a quantity. You're combining those. I want them to get those conceptual things, but then there's a time, to kind of move on. And so I said she was practicing the counting procedures so that it didn't link the problem and answer. And then she wasn't receiving an adequate dose. And so for our second intervention phase, what we did was we just continued practicing problems, sums to 10. And that was 12 problems removed. The kid already had those at mastery, so why continue to practice? We reduced, so then we reduced the set and only targeted sums 10 through 18. And this was 24 total problems. We did cover, copy, compare. You could have done tape problems too. But in this case, we needed an intervention that was incompatible with finger counting. If we just let the child practice counting, they would get faster at counting, but but again, if we think about the working memory piece and we think about some of the things you've heard about today, if you're constantly counting, you're filling the working memory, you're not able to really juxtapose your prior knowledge and your conceptual understanding and new things to really build to the goals that I think most of us as educators want to see. And so the new intervention plan, we doubled the time. So they did 2 pages, 24 problems per page with the sums 10 through 18 or 11 through 18. And then we also, after that, we did explicit timing with goal setting, self-graphing through the sums to 18. So we reduced the set, did cover, copy, compare, then did explicit timing where they combined all the problems, so the larger set. So we intensified by adding time, reducing the set, and then incorporating both accuracy and fluency building components, even though the child wasn't inaccurate. If you didn't allow the child to count, the child was inaccurate, right? Like they couldn't, like if you sat there and said, if you don't get it by 2 seconds, you don't get it. Right, then the child would have been inaccurate. So here's the results. And so again, the kid started at 4. We did the simple 10-minute, kind of counting intervention. We got him on the initial intervention. The child grew 0.6 digits per session. Then we went here. And these probes are the 11. So this is measuring the 11 through 18 probes. That's why it's so slow or low here. So the child started around 6, 7, steadily trended up well, and then really made a big jump. And then right here was the end sums to 18 probe. And so we completed 8 sessions of intervention. The kid increased 34 digits correct per minute. 4.25 digits correct per minute session increase, sub-skill remediated, sums to 18 was assessed, and the problem was solved. And so again, it took us less than 2 weeks to fix this. But the reason why this is important for the instructional hierarchy, right, is if we wouldn't have kind of understood that notion of procedural knowledge and declarative fact knowledge, and we wouldn't have kind of been able to go in and hypothesis test, we would have missed this, all right? And so what I want you guys to take away from this is focus on alterable variables. So what you're teaching, how much you're teaching, and how you're teaching it. So curriculum and instruction. Don't focus on unalterable variables. Pet peeve of mine, cognitive ability, blaming the child for their lack of response is just not a good road to go down. So if you use the instructional hierarchy with critical skills, I feel that, we can go ahead and we can look at systematically some of these curricular and instructional variables. Ask questions, generate hypotheses, test hypotheses, and make it a point to find the conditions under which the student learns at typical rates. So put the support in support teams. Bottom line here is well-designed MTSS should provide processes and tools to empower teachers to be active problem solvers to determine what curricular, instructional, and environmental variables a student needs to learn to be successful given an instructional task. And so, my hope is that through this instructional hierarchy, hopefully today and with the interventions and with the website, I'll give you guys some things to think about and move forward working with your students. Again, thank you, and I'll open it up for any questions. I know we just got a couple of minutes, but fire away.
Feel free to ask any questions in the chat. We have a few minutes. There was one that came through about, here's one right now. Go ahead. Do your materials include assessments that will help us know where to start in the sequence? That was the question I had seen earlier.
Yes, it's all there. There's manuals. There's things to look at. There's a placement guide. Everything is there. And also, never hesitate to reach out, email me if you have any questions. Again, spring math. If your district wants to put its money where its mouth is, and it cares about math achievement, spring math is a fantastic option. My stuff's free. Isn't involved. It's not, it doesn't splice things down into the detail that spring math does. But I think you'll find there's some similarities between the core kind of concepts of what we're getting at.